Okay, so if we look at the random variable x, which is given by the value we get when we roll a fair six-sided die. So if we're going to find the expectation, which we've already done, but we'll do it again, and the variance, we have to know the different discrete outcomes we can have, because this is a discrete random variable. Of course we can do a similar thing for continuous, like we've already seen. So we list all the values and their probability. So we'll have one column for x here, one row, and one row for the probability that the random variable big X is equal to little x. So the values of x we can have are 1, 2, 3, 4, 5, or 6, each with equal probability, and the law of total probability tells us that the sum of the probabilities of all the possible outcomes is 1. So if we've got 6 possible outcomes, all with equal probability, all the probabilities must be 1/6. Okay, so we've done this expectation calculation before, so we'll go through it just quickly. It's 1/6 times 1 plus 1/6 times 2, all the way up to 1/6 times 6. That's equal to 1/6, 1 plus 2 plus 3 plus 4 plus 5 plus 6. That comes out as 7/2. Okay, makes sense. Now we want to find the variance and ultimately the standard deviation. So we know our variance formula is is the expectation of x squared minus the expectation of x all squared. Okay, so we need to find the expectation of x squared. So the calculation is 1/6 times 1 squared plus 1/6 times 2 squared, all the way up to 1/6 times 6 squared. And again, that comes out in a similar way as 1/6, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared. And that is equal to 91/6. So now the variance is given by, so the variance of x is given by 91/6 minus 7/2 squared. That's equal to 35/12, and that's just approximately equal to 2.91. Okay, we haven't introduced the idea of standard deviation because the variance gives us a measure of spread, but it doesn't give us sort of the average distance from the mean. The average distance from the mean is the standard deviation, and the standard deviation is equal to the square root of the variance. And the square root of 35/12 isn't a particularly nice number, but it's approximately 1.7. Okay, so this gives us a nice idea of how the data is spread. Okay, we're likely to get the means 3.5, that's what we expect to roll on average, and then we expect on average to be 1.7 away from 3.5, which makes sense. Okay, if you do 3.5 minus 1.7, what do you get? 1.8. Okay, so that's 1.8 away from 0 and 1.7 away from 3.5, so it's in the middle. So we expect to be, because all the probabilities have equal outcome, we can get all these different values. Okay, obviously we can't roll a 0, so I don't know what I'm talking about that, but anyway, you get the point, hopefully.